Alright, how's it going? So this is just a brief explanation of kind of what we talked about on Friday with the whole green energy idea we came up with. So we're talking about green energy. And the reason they call it green energy is because it's using natural processes of actually making energy. Now, we have certain things, when you look at like fossil fuels, you look at it and you go, well, it's natural because it, comes from the ground. Something that's earth-made, not really man-made. We eventually chemically harness it so it can become gasoline from oil. But when they're looking at green energy, what they're looking is they're looking at zero waste, and kind of what we were working on creates that zero waste. Now, if you remember from your project, what you did is you set up something that acts like a fan. And as it acts like a fan, it's because it can spin, circularly. Now yours doesn't exactly look like that, but yours is more of a spiral that kind of like loops down like this. Now the whole thing is, it's because it's got a little bit of tilt that it does spin. And you look at a fan, and if you look at how propellers on a plane are, they are tilted just slightly that way. So as air passes through them, it'll hit like what we'll call the high side. Because let's say it doesn't lay flat like this, but it tilts a little bit. So as the air hits this high side, it's then forced to go this way, which then pushes the fan as it goes across. Because you remember what we were talking about with Newton's law, that any action creates a reaction. So there's the action of the wind being pushed in this direction, and it pushes the fan in the opposite direction. The same that we watched a rocket work. And how your air current is being generated is through heat. And as you know, that heat, when you heat something up, you cause the atoms to move further away from one another, causing it to become less dense. And so as the atoms and the molecules become less dense, they also become lighter. And lighter things always want to rise. They want to rise and sit on the top. And I don't think in your class they really had too much of it, but some kids were talking about when we have like the water, like when you have like the stackable liquid, so like you'll have like the water down here, and you have the oil that'll sit on top of it. And because it's less dense, it wants to sit on top of the oil. It wants to separate. It doesn't want to mix with it. And this is the same for air too. Is the lighter air, the warmer air always wants to rise higher. So what you have is you have, we're kind of thinking of like the three ways, and we talked about this at the beginning of the year, the three ways that that heat can be transferred. And there's either going to be convection currents. You can also have radiation. And the last one is conduction. And remember, this one's through touch, this one's through empty space, so it's like the sun's heat travels through space, there's nothing that's passed through. But convection currents is something that's traveling through a fluid. And because it says fluid, don't confuse it with being a liquid. Because air considers a fluid, even though we don't consider it, obviously we don't consider it a liquid. And so you have this air, and the heat is traveling from down here, where the air is hot, and it wants to rise up here to where the air is cooler, because it wants to sit on top of that cooler air. And the reason it's hot down here is because, well, you're using a bulb, but we could do that in different principles too. Now, your basic design is just pretty much you're having something that's generating heat, then it causes the air to rise, because remember, this air is heated. And as it rises, it comes in contact with your fan, which in your case is the spiral. And as it comes in contact with it, remember is that every action requires a reaction. So it hits the fan, causing it to spin. So the fan's going to spin. And as it spins, what you could do, theoretically, is you could put a generator on top of it. And all a generator is you can take like some copper wire, and you can take this copper wire, and as it spins inside, you're going to have a magnet. So inside there you'd have a magnet. And as it spins, this generates electricity. The magnets and the copper wire react with each other, causing electricity, and you are actually able to, you can either use or you can even store it. Now, the problem we run into is that the heat source that you're using, a light bulb, actually requires, generators using other types of electricity coming from a power plant. But theoretically, what you could do is you could possibly use, because here you have the Earth, you have the Sun, and we talked about the places that heat can come from, and you get a lot of heat from the sun. Most of the heat that Earth gets is going to come from the sun, but you also have heat rising up from the Earth. You have vents, thermal vents, you have hot springs, you have all these different things that's generating heat that that comes out of the Earth and it rises, because as we know, heat rises. It'll heat up the air close to it and it forces it up. Now, this is a lot hotter than a light bulb, so you could actually build a lot bigger of a fan to actually be influenced and be spinning by this. This also would produce no waste, because the only waste that's being produced is the heat escaping the Earth, and it's doing it all the time anyway. And it's not bad for the environment. It's something that's been going on since Earth's creation. And so what you theoretically could do is you could take this, make your model bigger, and you could actually create a type of energy where you could build a fan over a thermal vent, and it could take Earth's heat as it rises to cause this fan to spin, which is hooked up to a shaft, which would be connected to a magnet, which would spin inside of a copper wire, and this would be able to generate electricity. And so theoretically, that's something that you could do. So what you're going to want to do is, as you get ready for Tuesday, is just kind of build, obviously set up the same design you have, and show them that it's kind of like a prototype, and that's the word you want to use, because obviously, we don't have the power or resources to, find a thermal vent, especially, you're not going to find it here in Las Vegas, and build one of these things to show people. So what you do is you build what you call a prototype, and you show them the basic principle that's happening there with the lamp, and then the spiral on top. You show them the basic principle of that, and then on your board, maybe you can make a drawing, or we can make, maybe we'll do this during lunch tomorrow, maybe we can make a picture of kind of what's happening, of what we propose you could possibly build, give information on the sides about the theory behind it, maybe on this side talking about where energy comes from and what green energy is. Then right here you just kind of describe, what you could do with this. So that'd be something that'd be really cool, and not only would it be good for our science fair, but it'd also be something that'd be really good for the UNLV science fair that comes up in the spring, and you'll have a little bit more time to work on it for that. So again, if you have any questions, just make sure you email me, and I'll get back to you on that one, okay? All right, awesome. Take care. Bye.